Get your day started right. From our shack to yours, this is Coffee and Ham Radios. We are live in 5, 4, 3, 2, 1.
Good morning, everybody. And if Jim hit the button correctly, we are good to go. Well, here he goes, already starting.
I don't know what's worse. People whining in the chat that we ain't starting fast enough, and people whining on the stream side over here at each other.
We ain't starting fast enough.
Right.
But you're lucky enough to be witnessing another episode of Coffee and Ham Radios, where we have the friendliest bunch of hams this side of QRZ and actually talk about amateur radio.
And we try to be drama free. I mean,
yeah. And I'm just going to give a warning right now. I got something down in my gut that ain't setting right, so I might need to take a break halfway through the show. If you understand what I'm saying, I don't know what's going on.
Oh, I thought you were talking about SWR.
No, I'm not feeling 100% this morning for whatever reason.
Well, I got the backup. I'll do the quick taken care of.
Right.
All right, back, folks. Everything's good.
Yeah, and maybe we can play a commercial or something like that.
I was thinking we could put up a big sign that says code 2.
right, something like that.
Apes throwing deuces.
That's so right. Thank you everybody in the chat for being here this morning. Is the moral of the story. Lord. James, what do you got going on over there? Let's do the round the horn, as they say.
I am working through getting Brandmeister tied in so we can get D-Star working, because it relies on Brandmeister on Toads Digital. I hope to have that working today.
Nice.
Brandmeister.
Well, I mean, it hasn't worked for 3 years. Why would today be any different?
No, it works. It worked for like 6 minutes.
It works. It's worked since we moved it. Once we moved it off DigitalOcean, then Brandmeister went radio silent with changing anything on the ticket. And what it looks like they did, if for any of you that care about this or understand it, we told them we were going to use the 3104 master, but apparently they put us on the 3102 master, have not touched the ticket since December 4th. And so I just randomly started trying different Brandmeister masters last night, and guess what came up? 3102. It's like,
so we're good then, right?
Well, not yet. I got to fix a couple other things, but yeah, it should be up today with
D-Star.
D-Star.
To get started. That's what he's doing.
Tio, looks like you're about to go fishing for some of the world's biggest largemouth. What is that hanging on the wall?
Oh, yeah. Look at that.
That's my plug right there.
That's how I reel them all in.
And I got a DMR video or two to do today. So
how about that?
Yeah, I had a work trip last week. That's why I was out on Thursday. I got to visit the NASCAR Hall of Fame, so that's pretty cool. I'll have a video on that on my Living for a Living channel.
That's awesome. I'm not so much a fan of NASCAR, but I really am a fan of the lifestyle. You know what I'm saying?
Run and shine.
Right,
wearing jorts.
Sitting out in the field drinking beer all day while people driving in a big circle. It's a good time.
You probably just after the ladies, because those are some quality ladies in the infield. Yeah,
they after me.
You know what I appreciate in a woman is a full set of teeth. I got
right. I mean, there might be 3 or 4 of them.
You got to get 3 or 4 of them around to get the full set. But
and the important question is, do they have their own teeth? Right?
Yeah.
Are those your original teeth?
Keep in mind, I'm sure there are some NASCAR fans watching this, and we love you all.
Listen, some of the best times I've ever had were at the NASCAR race.
Yeah.
Chuck, what do you got going on down there?
Well, I just put a couple videos. One of the videos I put out was to help people build the Apollos, or anybody that's building a in-fed half-wave, because we found a common mistake, or just something people are missing when they hook up the ground side of the wire. And I did the Quartz Fest Poseidon thing that Tio and I both put a video out on, using the Poseidon out there on a POTA. And I've been building antenna kits, getting ready for tomorrow night.
When you
we ran out for one day.
What exactly do you mean when you
don't start this again?
Oh my God! Leave it alone. Let it die.
The guy that doesn't build the kits, has never built the kits, wants to tell us how to do it. Let's just say that, and I'll tell you which guy that is.
Listen, I worked in a pizzeria, and we had an assembly line. I know how.
I'm sure the pizzeria is almost the same as building antennas. But yeah, I've got a bunch of kits ready. We're doing. I guess tomorrow night we're going on Jason's H2 our Ham Radio 2.0. And he is going to attempt to build our Aries antenna. I'm sure he can do it.
Did you flip the dough, or were you pounding the meat?
Oh,
to me?
Yeah, I mean, you're the pizza professional.
I was
talking about the pizza part.
I was the saucer. I put the sauce.
Sauce.
Oh, that's
That worries
the
me
most
even
important
more.
part, man.
It is.
Yeah.
You got to get that sauce just right, son, or the whole pizza's ruined.
That's right.
But our Aries is back in stock. It was out for a day. Sorry, guys. We're having a problem
the good
getting
news
wire.
is everything is pretty much in stock right now, and the
Oh,
Aries
and-
Light is in stock. So, and we
And
only
the-
have a few of those, and we're not.
Let
gonna
me
sell
explain
any
that
more
one
of
to
those.
you. Let me explain that one. That's the older version where before we gave 100 feet of wire, and it's like
It's like 70
80
feet
some
there.
feet of wire. Yeah, 80 feet, right around 80 feet. I forget exactly.
Maybe 83.
And we have six of those left. If you only carry
91.
care about 40 and higher, save the $5. I think it's $5 cheaper for that kit.
Yes.
We just went to an easier thing where I can just drop wire instead of have to wind it. So that one will come with a winder with the wire already wound on it. It's the only real difference.
That
And
is
if you
the
don't care
only
about
difference.
80,
Other than that, it's the same antenna. Yeah.
yeah. If you don't care about 80, and we're not even saying, even if on 80, if you make it 71 feet, Abe, I think you can extend it farther. And what I would do is I'd make it to where you just extend it.
But
not leave it on there all the time.
antenna is officially designed for 40 through 6.
Yeah.
And I
if you
think
get-
anybody that wants 80 is not going to.
They're not going to have as much
antenna.
fun.
Well, they'll
Right.
be
But
able
if
to
you-
complain just as loudly without an antenna as they do with.
Right.
It'll be fine.
Right.
But if
All
you
right.
don't think it works on 80, watch Michael KB9 VBR work 80 on that antenna, and he does really good with it still. I mean, 80 is going to get you a few hundred miles, maybe. Anyhow,
Thank you,
Todd,
Ted.
most of
thank
the time.
you. Appreciate it. I've been sitting on go waiting for Chuck to stop. And
well, we don't
50
do a
cents
good
on
enough
Poda,
job
that's my
explaining
goal,
stuff
too.
sometimes, right?
I would agree. I would concur.
yes.
And I don't think people understood why we had the light. It's just it's the same exact antenna. It's just a little bit less wire.
Ken's saying give him a G90 and it'll work on 80. And that is
will.
you will tune it on 80. One of the reasons that we say, hey, or at least I say, hey, be somewhat judicious when you're using it on 80. It's a T140. So 80 meters generally tends to heat a core up pretty quickly. So if you're going to do single sideband, you're probably going to be fine. But if you start cranking FT8 on that smaller core, it's going to get hot.
Yeah.
So is that the way it works? The lower the band, the more transformation magic needs to happen, the hotter it gets.
Yeah, essentially. So they definitely get hotter. So that's why a lot of times when you look at like 80 and 160, they'll actually use a different mix on those cores that have a higher permeability and temperature rating. Here's Thump. He's woke up.
Thump's already starting. He's already starting on you, man.
Yeah, I want to know if he made the chicken last night. I was texting him and he was saying he was putting together some chicken, but he was on the fence about it.
Was he doing the beer can chicken?
He was doing like a sweet and sour type chicken, I think. Like a
We don't do beer can chicken here on Coffee and Ham Radios. We only do spatchcock.
right. Well, the thing is, when you do a
Right.
spatchcock chicken, it makes it look like you're that much better of a pit master than if you do a beer can.
I had pheasant the other day.
Like
My brother,
like a quail or something like that.
no, like pheasant, like fried
Like
pheasant.
it's bigger.
It's a bird.
It's a bird.
I know you don't get
know.
out much, Abe. It's a bird.
Well, I mean, I know
It's
it's
from
a bird.
China. A bird from
That's
China.
From one indoorsman to another, it's a bird.
But like, isn't it the pheasants? There's like more than one designation of a bird.
Oh,
that
there's
can be
the ringneck pheasant. And what's the other one?
Ringneck.
I don't know. I didn't go
That's
on
the
the
only
hunt.
one I
My
know.
brother-in-law and some of his buddies went on a pheasant hunt, which is more of a pheasant roundup and execution kind of style. It's not really hunting. They know where the
Right,
birds
with a
are
cool,
at.
Yeah.
with a cooler full of bush light.
I'm sure. Well, knowing my brother-in-law, it'd be Coors Light, but yeah. And so,
Water.
my sister-in-law, Julie's
Ryan, that
sister,
sounds
brought
good.
over a mess of pheasant, and it was delightful.
Yeah, it does.
I had
And
to
you
eat
deep
it with
fried
my.
it?
I had to. No, she already cooked it. I had to eat it with my pinky out because it's fancy, right? It's
So-
fancy.
Real
Also, it's under
quick.
glass.
I'll settle this debate right here, Todd. This is going to be really easy. Todd's got a fancy pants rig expert, which is nice, and we appreciate that about you. But it doesn't need to convince you. You're a ham. It's $50. I don't know why you don't have two of them. There's no convincing when it's under $100.
Right.
I
All
get
right,
them
here we go.
confused. I get the get them confused.
Oh
the
crap! Here's the
NanoVNA and
200
the other one.
slides, folks.
Yeah.
Hope your
So
coffee's warm.
this is
Wait a minute. Let
original.
me get my FT8 set up.
All right,
Oh,
this
go
is
ahead. I can do
original
that.
NanoVNA, and they call it the H that came out. We'll talk a little bit about some of the different models and designations, but I want to say it came out about 3 or 4 years ago. And when you order a kit these days, this is about what you get. Now, it might vary a little bit depending upon where you order it from, if it's real or not, and what model you get. But in a nutshell, it is a 2-port device. And on here, you can see the top one is labeled port 1, and it's also labeled S11. The bottom one's labeled S21 and port 2. Sometimes they'll be labeled channel 0 and channel 1. But what's important to remember is the top port is a transceiver. So it can transmit a signal and it can receive a signal. The bottom port can only receive a signal. And that's going to be important when we talk about things called scattering parameters. And scattering parameters are the way that we measure devices. In the video,
That's our S numbers, right?
Yes. And we might call them DUTs, like a device under test, as a generic term to mean anything like an antenna or a filter or a trap or anything like that. But your NanoVNA, the original one is a 2.8 screen measured diagonally, and it is capacitive touch screen. On the top of it, it has a jog button and an on-off switch. And some of them even have an SD card slot where you can save calibrations, you can save sweeps, and you can save screenshots. They come with this goofy guitar-looking pick thing, and I don't like it. People use those. I don't like them. But it also comes with a set of calibration standards. And calibration standards are pretty important because your NanoVNA is only as good as the calibration you have applied to it. And so calibration standards are a short circuit, an open circuit, a load, and a through. And then we'll talk a little bit about how we use those. It'll come with 2 pieces of coaxial cable, which is pretty cheap. So you may want to upgrade your coaxial cable to a little bit better one if you decide that you are serious about measurements and you want to use your NanoVNA often. It also comes with a traditional stylus, and that's what I like to use because my finger's too fat and chubby. And so when I hit the buttons, I'll hit multiple buttons. So that little stylus comes in handy. These days,
no fancy guitar pick for you.
Yeah, these days they'll come with a USB-C to USB-C cable and a USB-A to USB-C cable. And you would use those cables to charge your device or connect it to your computer for using the computer programming software and updating your firmware.
So it's evolving.
It is evolving.
All the way up to C.
So before you get into that slide, Abe, real quick, there's Brett Glass watching us over on Twitter. Thank you very much, Brett. I didn't know this, but we can't comment to Twitter because there's no such thing as commenting on my side. I can't. Maybe I'm not smart enough to find it, and Brett is.
Yeah.
I didn't know they made a NanoVNA without an integrated screen.
Well, it would be a VNA. There's a couple of them. So so actually, if I take that back. So if you take a look at the first bullet, the original NanoVNA was an open source project by Eddie. It was sold as a kit, and it became popular with RF hobbyists. And so if you had that kit, it's a potential that you have one that didn't have a screen. But there's also other VNAs that are out on the market that were a little bit more money than the NanoVNA. And then what you would do is you would hook those up to your computer, so you would have a way to control them. So the one that we just showed was an NanoVNA H, and that was developed from the original by a guy named Hujin, and that's the one that became commercially available about 3.5 years ago. And it included a lot of improvements like the touchscreen, the extended frequency from 300 to 900 megahertz. And then Hujin later made the 4-inch NanoVNA, the H4, and that's the one that we typically always talk about and tell people to go buy off of RNL. But the original NanoVNA only worked up to 300 megahertz. And we're going to talk a little bit about why that was the case and why it's a little bit of a challenge in some of the NanoVNAs today. So they would use a chip, and I want to say it was an SI5351 as its signal source. It might have been a 5153, but either way. Typically the price, Liberty Cave. Sometimes the clones actually cost more. And also the quality of the components. So like if you get a fake one or a clone, a lot of times they don't have good shielding in them. So when I was talking about that chip, the SI5351 or whatever it is, that when it generates a signal, it also generates a cloud of RF around that. And if the other components in your NanoVNA aren't shielded, you get noise. And what that noise does is it raises your floor, right? It raises your noise floor, and it lowers your essentially it lowers your dynamic range and limits the amount of measurements you can make. Also, you may have problems getting a signal that is on frequency. So there's a thing called the NanoVNA F, and that was developed with a different touchscreen, a different processor, and different firmware, and is not related to the NanoVNA H line. So the people who make the NanoVNA F will constantly call the NanoVNA H copies or clones, even though they made them first and they are the originals. The NanoVNA H people say the exact same thing about the NanoVNA F people. So that's where a lot of folks get confused. There's also something called a NanoVNA V2, and that was developed by HCXQS and some guy named Owocom. And they have extended frequency. So these are the first NanoVNAs to start getting up into the gigahertz and multiple gigs ranges. And they don't rely on using harmonics. And so when I say that, the SI5153 chip that I mentioned earlier, that is only can generate a signal up to 300 megahertz. And so if you wanted to have a test signal at 500 megahertz, you are using a harmonic of a fundamental created at 250 megahertz. And I got a screenshot that kind of shows why it's a little bit of an issue. But
So sometimes we like harmonics.
yes, we do. And the NanoVNA V2 uses an ADBS. I'm not real good with the chips. I think it's an ADBS chip, and that can generate signals up into the 1.5 gigahertz range and potentially even higher with less noise and without using harmonics. So the NanoVNA 2 is probably the best one that you would want to get, but they are significantly more money.
How much? What price ranges are you talking?
I think they're
if you're
going to
go out and buy a Nano today, what are you buying?
So this is NanoVNA V2, and this is about $400. I don't know if I would buy that. Here it is right here. I don't know if that's what I would buy. There's me double time. I always recommend the NanoVNA H4. That's the one I use. I think you can get it off of and I got one right here. Just give me a second. I got mine off of R&L, and it was about $78, I think. And it does use the harmonics, which does have a decreased dynamic range, but it's not enough to make a difference for most of what I do. So if I woke up tomorrow with no NanoVNA, I'd probably buy this. If I wanted to spend a lot of money on it, I'd probably get one of the cisjoint the 7-inch screen VNAs, but they're about $100. Where
does the Libra fall in that?
I really like the Libra, and the Libra's actually got a really strong following. So the Libra VNA is not a NanoVNA, and it has extended capabilities beyond what the NanoVNA can do. I think they're about $500 these days.
Yeah.
The problem is it's strictly in the house. Like you can't take it with you because it has to use a computer. It does not have a screen on it, and that thing gets hotter than a stolen pistol. You know what I mean? Like when
it's a shack warmer. Mm-hmm.
Yeah, I mean it's a nice piece of equipment, but it's definitely a little bit more complicated.
It has a spectrum analyzer and a signal generator in it. A tracking generator equivalent,
yeah,
I believe.
It's definitely a nice piece.
Yeah.
And then I have, given the success of the platform, there are a lot of copies, fakes, and clones on the market.
Except no substitute.
Yeah, so here are the main VNAs, and I just did a picture here for size comparison. So the smaller one in the middle is the original NanoVNA. And you can get those for about $50, like Tio was mentioning earlier. And there's really no problem with them other than the screen's small. So you got to use a stylus, and the text and stuff like that's pretty small. So if you take it outside, you might have some problems reading the screen. And if even inside, if you have eyes like me, you might have some problems reading the screen. So I just opt for the NanoVNA H4, which is the one on the upper left-hand side there. It's a little bit bigger. And these all go up to about 1.5 gigahertz today with newer firmware. So if you have an older one or you buy an older one, it might only go to 900 megahertz. So you just have to do a firmware upgrade. I did, Hertz. I did. He and I will joke around with each other from time to time. And then on the right-hand side, what we have there is the NanoVNA V2. And I got to tell you, so with this V2, none of the ports are labeled, right? Mm-hmm. So I was doing a firmware upgrade on it. And it says that in order to get the device into DFU mode for device firmware upgrade mode, it says hold the left button in and while you turn it on, and I was holding it facing up instead of facing down, so I was holding the right button in because none of this stuff's labeled, and it was a very frustrating experience. I said many dirty words. There is that is the light VNA, Andy, and there was actually some drama around the light VNA when it came out, where a lot of people were saying not to buy it, but I'm not. I don't have one. I've never messed with one, so I don't comment on it.
What was the drama?
I don't remember exactly. I think it was incorrect readings, or I don't know. I really don't know.
Okay.
There's a guy named Joe Smith on YouTube. He's one of the best lab guys on YouTube, and he does a whole thing about the light and why he didn't like it. But I watched it late at night when I was drinking Miller Lights. I don't remember exactly what he said.
Okay.
All right. So the mini VNA, Tiny Plus. So the thing is, a NanoVNA is not an SWR meter, and so a lot of people will reach out to me and ask me questions, and they'll say, "Well, how do I hook this up in line with my radio, my antenna?" And you don't. So if you fed a radio into your NanoVNA, you're going to smoke it. And the thing is that the NanoVNA generates its own signal for measurements, so you don't need to use a signal from the radio. So that's a NanoVNA SAA2N in the upper left-hand corner. And I had one of those. I liked it. Yeah, you have one too, I think, don't you, Jim?
You sent it to me. The broken screen one that I...
Right, so you has to hook to this.
Yeah, which is how I'd use it anyway. It's easier that way for me. It works fine.
Yeah, but a lot of people see those connectors on there and think, oh, I can just hook this up in line. And it's really a instrument for testing stuff. It's not, I know an SWR meter is the same thing, but it's different. SWR meter, like that MFJ in the middle, is designed to be in line with your antenna system. So your coaxial cable to your antenna and gives you real-time measurements. The NanoVNA is an analysis tool that you would use to troubleshoot, diagnose, tune an antenna, and then take it out and put it back in its box and then operate on your merry way. I also put a Rig Expert in here because the Rig Expert, like the NanoVNA, is not an SWR meter. People call it that. They're like, give me my damn SWR meter. It's really an analysis tool. Now, when you talk about the Rig Expert, essentially what it is, it's twice or 3 or 4 times the price of an NanoVNA with half the functionality. And
that's just hurtful. That is hurtful, son.
Right. But the thing is that with the Rig Expert, it can't generate the same type of signals that you can on the NanoVNA, and it has one port. So it works solely off of reflection coefficient data, based off of an S11, and we'll talk about scattering parameters. You can't do any type of through measurements with it, and I find that to be extremely limiting. Now, do a lot of hams do through measurement stuff? No, they don't. But if you're one of the ones that do, you can't do it with a Rig Expert. So,
well, it's a different tool for
$1,500, right?
For the field, I still think a Rig Expert beats the Nano just because it's a whole lot less fiddly and a whole lot more readable.
For all the field work that Jim does.
It doesn't know for whatever.
Okay, let me say that. So for the field, I think that
you guys
Rig
don't even
Expert's
know
a lot
what
easier.
I do, right? I mean, whatever.
We only know what you tell
That
us.
make more
I
sense?
just don't POTA, right? Because I don't care about sitting in a park all day.
Thank you, Chuck.
Don't listen to POTA. The POTA police will be on your ass if you say anything bad.
I'm going to send them to your house because you don't POTA either. You don't POTA more than I don't POTA.
I think POTA is the most wonderful program in the world. That's
I didn't say it was
official statement for the record.
We love
Ape
POTA.
up on POTA.app. Look up his call sign on POTA.app. You'll see all the activations he did. He's got about 17 kilo awards in 4 different states.
Right. You're right over there, James.
So
he blew out an O-ring.
I'm glad I don't have a watch on. I got to save my wedding band at least.
Just a quick question for Ape. AUR sync, Rsync. Is that that's a legit one, right?
It is.
Yeah.
Yep.
Yeah.
Okay. Just wondering.
Yes, Ape is correct.
Not that I'm
the Rig
buying
Experts are a little more pricey. The low end RE is probably about $200.
Man, when I bought mine, it was reasonable.
That probably only goes to 30 megahertz, and then the higher frequency you get on the Rig Experts, then the more it costs. So,
well, I think this one goes to 3 gigs, right?
If that one on the screen is 3 gigs, that's probably $1,500 or so. Yeah.
Yeah, that's what I was saying. So, like, if I bought a Rig Expert, I would probably buy the AA35 Zoom. And the reason is because
By the 55.
yeah, one of those, right? Because they're inexpensive, and
Yeah.
you could do a quick sanity check for SWR.
Inexpensive-ish. Yeah.
Yeah, but
I bought the 35 or the 33 or whatever it is, and I wish
I've had
at the time
three
at the
of
time I wasn't planning on doing ham radio, so that was a mistake.
so Jameskin, I like the SAAN2. I just had like 7, actually it was probably more than had VNAs. And I was just in a point where I have too much junk in the house and I wasn't using it at all. And so I just got rid of it. Now the other reason I don't like it.
Oh wait. Okay.
Did we lose him?
No,
Right
he
here.
was just. I thought he was taking off.
Is I like
Oh.
the cis joint better. And so this is my 7-inch
Bring it
SVA
up, man.
4401A, and it's just
Holy
a big
moly, that's big.
yeah. And so I
I mean, I've
like
seen
it.
your head in person, which is pretty big. So
Well, there's also
Do you
there's
take that
also
one
a
out
depth
portable?
perception issue, right? It depends what you mean by portable, but like if I was coming
The
over to
front
your
yard,
house to play
backyard.
antennas, I would bring this.
That one is. What did you say? That one's about $600 or $700, right?
Yeah. But it's nice. So all right. So one of the things I did a video on this. With the NanoVNA, they use these SMA connectors, and SMA connectors are prone to wear out, and you're constantly taking things off of your NanoVNA. So whenever you do a calibration, you have to put 4 devices on or off to to complete the calibration. Plus, a lot of people use adapters and jumper cables and stuff like that. So, like, let me see if I can get this undone real quick. So, like, here's just a little BNC connector that I have that goes to BNC goes to SMA, and I connect this to my NanoVNA all the time. And so when I have this on here, I want to wear this piece out, not my NanoVNA SMA connector.
Right.
But also in that picture, what we had in there was these little adapters that go SMA male to SMA female. And I put those on my tiny SAs. I put them on my NanoVNAs, and I leave them on there all the time. And what that does is it extends the life of that SMA port. Now, if you're handy, you can open up the NanoVNA and you can replace these SMA ports if you want, but it's a pain in the ass. And some people will be like, "Oh, I'm
Piece
so
of
handy
cake.
with an iron. I got no problem doing that, boy. I'm in there and out
Let me
quicker
get my
than-"
Radio Shack iron out.
Yeah. So I
It's
mean,
like-
whatever you want to do, but to me, I spent $4 on adapters and I extend the life of my NanoVNA.
what's your time worth? Yeah.
So
And then you calibrate those out anyway, so it doesn't really affect your measurement. in
yeah.
the
So
end.
when you extend that out with the adapter or with the cable, you can calibrate it later. And what that does is move your reference plane. So when you calibrate without them, your reference plane is the SMA connector. You can extend that. And NanoVNA also comes with a function called electrical delay. And so I have a video called NanoVNA Tips and Tricks. And what you can do is you can use electrical delay to cancel out any delay because of an extended port that you're using with an extra cable or something like that. Now, the challenge gets in there is when you start extending your port and you're using different adapters, different connectors, different coaxial types that have different dielectrics, you do have an impedance mismatch issue, which could affect your measurement. But it's important to measure in amateur radio. We're not doing heart surgery, right? We're just playing radio. So it's okay to be close. You don't need to be exact, if that makes sense. What happened?
Nothing.
Nothing.
We're all waiting on the next gem to drop from your mouth.
All right, well, let me put this back into the
And I was getting a link for the people.
people. All right. So I wanted to mention resources because a lot of people will ask questions about, well, how do you do this? Or where do you get the menu? Or how do I get the firmware? How do I get the computer software? So you just want to go to nanovna.com. And there's this website that's got all the wonderful links that you're ever going to need. And it's a lot easier for folks to go here and get an answer than sometimes it is to scour the internet and look through news groups and all those kind of things. So we're not going to go through this, but every NanoVNA ships with
I hope not.
every NanoVNA ships with a menu structure map.
Which
And while
is
this
very
looks
useful.
complicated, it's significantly less complicated than your average Yaesu radio.
Right.
And there's probably a lot of
That should be
a lot of
easy.
things on here that you'll never use anyway. You can also get this off of nanovna.com, and you can print them out. Now, the NanoVNA structure map will be different for different VNAs with different firmwares, right? Because new features are added or removed, and some VNAs do things that other ones don't. Mike says he's getting weird results on his NanoVNA a year ago. He opened it up and the SMA had come loose. I was able to resolder and it's fine, but I'm more careful about reducing stress on it now. Very helpful tip, Mike.
And then Arnold has a question for you, which we kind of covered already, but
yeah, but so you can save the calibrations. And so like I was talking to a pretty seasoned ham and they were telling me how much they hated the NanoVNA because they had to calibrate it every time they used it. And so I explained that when you do a calibration, you can save them. It has 6 memory slots, and then you can recall those calibrations at any time. So you don't have to calibrate it every time you use it. I saw Tango Oscar Mike. What's up, man? He ordered a NanoVNA this morning without knowing what the stream was going to be about.
Adam Dennis made it in here too. I'm amazed he's awake this early.
Yeah, I am too.
We thought Chuck wasn't going to wake up this morning because his old lady is out of town and he was unsupervised. Right. So
no. I was watching Lawn TV before we got on here.
Mr. Seidman.
That's a smart dude.
So just a couple of different key points about the NanoVNA is that different ones will have different firmwares, and that means they'll have different command structures or functions. So it's just something to keep in mind that they all don't behave the same because they're different. And we talked a little bit about dynamic range and harmonics, and I think I got some more conversation about that we're going to cover. So the NanoVNA typically has 101 data points, and that's a little bit of a limitation that you can get around when you use the NanoVNA Saver software. You can increase the number of segments and data points. But essentially what that means is that if I take a frequency span, like say I'm going to scan from 7 megahertz to 28 megahertz, I only get one data point. I only get 101 data points across that entire span. So the bigger my span, the further apart my data points are, making my measurement less granular than I might want it to be. Some of the newer firmwares and newer VNAs will do up to 401, and I believe there's some that do 1,001 data points now. But if you use the segment feature on the software, you can say I want 10 segments, 20 segments of 101 data points. And then you can get up to, I think the biggest I've done is 10,100 data points.
And that took a hot minute too. I'd bet.
It takes a lot longer when you do that. There's no doubt about it.
Yeah.
The other thing is NanoVNA, when you turn it on, is a little unapproachable, right? And so I know one person now who's a huge NanoVNA fan, but when they said when they got their first one, they threw it in the trash. So if you look at these screens, there's a lot of stuff on there. You can toggle these traces on and off. So you might only want to look at SWR. You might only want to look at a Smith chart. So you can reduce the noise and clutter on the screen to make it a lot more usable. And of course, you can use the software as well. The other one is that when I just mentioned it, you definitely want to save your calibrations. So it makes, because a lot of people are like, I can boot up my Rig Expert and get right to testing. You can do that with an NanoVNA if you save your calibrations. It is equally as fast. And then some of the newer ones come with a micro SD card. And
so also you can also, when you save your calibration, you can also save it in that band and that mode and that frequency range. So you just like, if you're a 20-meter fan like I am, my NanoVNA set up for 20 meters. I turn it on and I check my SWR and I go to town.
Yeah. So what I do is I have a calibration for 40 through 10 because that's pretty much all I would ever operate on. And so when I plug an antenna in, I just do a quick sweep. If there's something on there that catches my eye, then I will go to my calibration for 40 meters or 20 meters or whatever that one where I think that there's an anomaly. And that way I'll get a more granular reading. But you absolutely
He can say the word anomaly correctly.
I just did anomaly.
I know. I'm never mind. You mangle half the English language.
Well, you know
talk about anomaly like a boss. Like,
dude, I have impeccable pronunciation. I don't understand what you're talking about.
Yeah, I just like how I watch your eyes go a little cross-eyed when you say picture, because I know you want to say picture.
Picture. I really have about 4 different accents depending upon the audience. So it makes it very difficult. And then, like, if I'm taking my medication, my Miller Lite, sometimes they'll intertwine with each other. It makes it a little bit more difficult.
You got it, Bryant.
Jesus. Okay. Woo.
So I want to talk a little bit about dynamic range. So if there's one thing somebody like Don could complain about, it would be the dynamic range on the NanoVNA that uses the older SI 5153 chip or whatever it is. And so if you take a
I
look
don't
at
think
this,
he's even here.
this is the specifications for the NanoVNA H4. And when you look at measurements from 50 kilohertz to 300 megahertz, you have about 70 dB of dynamic range. It drops to 60 when you're operating between 300 and 900 megahertz. And then it drops even further to 40 dB of dynamic range when you're at 0.9 to 1.5 gigahertz. And this is because, and I got a picture coming up where we can take a look at how this exactly takes place. But the chip can only generate a signal up to 300 megahertz. So we use harmonics of a fundamental to get your measurement. So the reason dynamic range is important, dynamic range is the difference between your test signal and your noise floor. So if my test signal is only at negative 20 dB and my noise floor is at negative 70 dB, I only have a range of 50 dB that I can measure. That's generally not a problem. The only time I think that it could be a potential problem for amateur radio operators is if you are tuning a repeater at 900 megahertz, for example. You might not have enough dynamic range to measure the amount of rejection that you would want on your repeater. But for testing antennas and bandpass filters and stuff like that, or coax cables or chokes or balance or any of that stuff, you're fine. So this is a picture where I took my NanoVNA and I fed it into my Siglent spectrum analyzer. And what I asked it to do was create a spike. I wanted to create a test signal, a CW carrier at 800 megahertz. And that is here with the red arrow on it. And so when you look at the output across the bands, I see a fundamental signal here at the blue arrow at 200 megahertz. So that means that this is a fifth harmonic of that signal. And then you can see in the upper right-hand corner, it's negative 17 dB down. So what it's showing is I've lost about 20 dB. So I went from 70 dB to 50 dB of dynamic range, which is pretty close to what the specifications on that said. So what that means is that I have less room between the top of that red signal and the noise floor to measure my device under test. Now, what I want to do is I called my friend Jim up and I said, I want you to connect your rig expert to your Siglent spectrum analyzer and create a CW carrier. And it don't do that, right? You can't just create a single tone on that, right?
I can do it on the Aeroflex 7100.
Yes. Is that, Chuck, this is where you ask if the Aeroflex is portable.
Yeah.
I mean, it's portable if you have
Is it portable?
backpack with a frame.
Thanks, Chuck.
Or
Welcome back to the show.
Or a porter with you. And not the kind
I'm
you
working,
drink.
man.
Making kits.
Some of us got to work here.
But so that would be something that would be interesting. I don't know what the dynamic range for the rig expert is. I did quickly go to the website and I tried to look it up and I didn't see it anywhere.
He's
I would imagine
expert hater is what he is. He just,
yeah. You know. I'm not a hater. I mean, I like him. I just don't like him that much. So,
see, I like POTA. I just don't like it that much.
Right.
Let's see you on FT8, Chuck.
Right.
I'm not doing FT. I'm working.
So there is some consternation in the crowd. We don't have Don here this morning, which is
Where is Don?
Unusual.
Well, Don would start in with his, I don't trust it. I just simply don't trust it.
That is what Don would say. That is
I don't understand why you need to trust it that much, though. I mean, for $50 and the range that it produces, 1.1 to 1, 1.15 to 1, it's fine.
But the thing is like, I don't understand the trust. It's not going to go empty your bank account or sleep with your buddy. I mean, what's the big deal? Like, I don't understand.
Well, and I think the thing a lot of people get wound up about with some of this cheap test gear, lower end test gear, whatever you want to call it. Cheap is the wrong word. Affordable brand test gear. I'm sorry, affordable test gear. There you go. We'll go
right priced, right sized,
right priced budget test gear. Listen, number one, you're not an NIST lab, right? You're not releasing an RF product that has to meet FCC specifications, although that doesn't bother a whole lot of radio vendors. And number three, it's all kind of relative. If it gives you an idea of what's going on, then it has solved your problem.
This device has a high price to performance ratio.
Yeah, it does. It honestly does. I'd rather have a rig expert. That's me. I like my rig expert. If I want to do this kind of stuff, I'm going to get on the SVA 1015 and not this.
I was going to say, I don't know why you're not using your oscilloscope instead of a NanoVNA. I realize they're different tools. Don't ruin the joke, folks.
Yeah, but the thing is that the NanoVNA has a learning curve. And so
he's gonna
Everything
lose
has a
the joke.
learning curve.
people will use the excuses to get around the learning curve. And I'm not saying that disparagingly. I'm saying it's true. And they do it with everything. Like you get people who are like, I just don't like the damn DMR. The DMR sounds all warbly, or whatever
It
the
can be
word is.
fixed.
Exactly.
It's the, or they're
Probably
like, I
their
don't like the
internet.
FT8. The FT8 is just a meaningless contact. And I'm like,
'Cause you
okay,
don't
so
understand it.
right. So a fake signal report and hearing about the weather where you're never going to be, right. And a prostate
Or
health
Ape
check
Scout,
update, right,
right.
is a meaningful contact. All right. I get it now. I understand.
Y'all go listen to 80 meters at night, and it's just, oh my God.
Or just rewind the show back 2 minutes.
There's that too.
All right. So hopefully that covers the dynamic range drama around the NanoVNA. So some of the uses for ham radio enthusiasts is antenna analysis. So like when I got my first NanoVNA, I'm being honest, man, I bought it because it was cheap and I could test my antenna, the SWR, because I needed an SWR meter because I was building antennas and I didn't want to spend a lot of money. And that was 100% why I bought it.
It's cheap,
So
and then you get 7 of them.
Right. Well, I think I've only paid for one. So you get one, you make a couple videos, and then the folks contact you. You can measure SWR, return loss, complex impedance. You can use it to test filter or trap responses. Some of the NanoVNAs will actually give you LC matching parameters. So let's say you have like a 5/8 wave antenna out in the backyard and it's not entirely resonant on the frequency that you want. You can have the NanoVNA generate an LC matching network for you that you can build and put on there and get yourself in line. You can do transmission line length, which is time domain reflectometry.
No.
You could do.
Wait, did you just goose him or what?
No, he just said it. I was waiting for it. I've been watching it. I'm like, I'm waiting to see what he says.
Yeah. And then you could do distance default. You can measure circuit gain or circuit loss through like an amplifier or attenuator, tuning duplexers and even diplexers for that matter, and much, much more.
And those are all pretty much standard VNA functions.
Yeah.
And the NanoVNA listen, for the price, it is cool. It is very cool. If you go look at used VNAs on eBay,
thousands of dollars
for parts only, are thousands of dollars.
Well,
for
because they
parts
don't know
only.
how it works either. I mean, they can't test it to tell you that it
Probably
works.
not. And yeah.
I looked some up that might be a little more legit, and they were like 14 grand
Yep. That must be a cheap one.
with no screen.
Yeah.
Well,
So
I guess
we
your
talked
computer's a
about
screen.
S parameters. The S stands for scattering. Why, I don't know. And the NanoVNA has 2 ports, one labeled S11 and one labeled S21. So I just put a picture of
Right, Dennis?
a band stop filter in here just to highlight how you can do 2-port measurements with your NanoVNA. So on the left-hand side in the middle, you have S11, and S11 does a reflection coefficient metric, and you can derive all kinds of stuff from that, like your return loss, your SWR, your complex impedance. And that is just an input and a reflection that comes out of that. And you measure that on your port 1 or your S11 port on your NanoVNA. And then I have below that at the bottom is an S21. And so the numbers mean that the signal is being measured on port 2 and generated on port 1. That's how you read an S21 parameter. And that allows you to do a through test. So with this particular device under test, this band stop filter, I could set a sweep up from about 50 megahertz to 150 megahertz, run a signal through this, and then on the output, I measure the delta between the original signal and then the signal goes through it, and I can see where there's attenuation. In the case of this particular device, it's called a FM band stop, and what it does is it attenuates signals generated by FM radio stations in your vicinity or your proximity location, whatever fancy word Jim likes. And what it'll do is by attenuating the signals, it will reduce noise in your environment.
So it's a notch filter for the FM.
Big ass notch filter is exactly what it is. And this one in particular is made for SDRs. Now they do make them for amateur radio, but I just didn't have a picture of one. Now, there's other measurements on here that the NanoVNA doesn't do. And some VNAs will have 4 ports. So you could do an S44, an S41, an S42. But typically with a higher end 2-port VNA, you can also do an S12, which is a reverse of S21, and allow you to measure stuff bidirectionally. With a NanoVNA, what you'd have to do is switch your test leads to measure it the other direction, because not all these devices behave the same way, both directions. So depending upon the filter network and how it's constructed, the topology of the network inside your device under test, your measurements can be different depending upon which way your signal's going.
So S12 would show you something like
what's coming into your radio.
Yeah,
right. So the S21 shows what's coming out.
Return loss. That's the word I'm trying to think of. Return loss.
Yeah. Yep. And then you can also do reflection coefficient on an S22 the same way you would do an S11.
Right.
But the NanoVNA does not have that capability.
So that's pretty much what the SWR bridge does on the spectrum analyzer, is gives you those functionalities on a standard spectrum analyzer.
Yep. We all like to talk trash on my PowerPoint presentations, but Liberty Cave says y'all need to step up your PowerPoint game. I'm just saying.
I just want you to imagine Chuck making a PowerPoint deck, because we ain't got enough time to help Chuck make a PowerPoint deck. And then
he's done it. Chuck, you've done slides when you did the vertical. What was it?
Yeah. Chuck would make a PowerPoint deck on antennas, and we would be here for 3 days while Chuck read our slides.
Yeah, but you'd learn something.
Slides. If I stayed conscious, yes.
I'm just not going to say anything about this one. I'm going to just let this one go.
Tom says
Chuck,
the
love
S
you,
is
brother.
actually related to the S domain. This is where the signal data is transformed with the Laplace transform. Super fancy math to make complex analysis easier.
Yep.
And I believe you, Tom. I don't know what you're saying, but I believe you. When you say it like that, it's convincing.
Tom is smarter than us anyway.
When you shut the ape out, I mean,
he's smart.
You shut him down.
And
so that's like a fast Fourier transform. It's a math transform. Yeah.
Yes.
I guess. I don't
transform
know.
is like,
Listen,
I think we're on 48.
I went to public school. I have no idea what he's saying.
you not only went to public school, you went to the best public schools that Baltimore, Maryland could provide. I mean, really, you're still standing upright.
I'm
Went to public school in Kankakee, Illinois.
Lucky to be alive.
The metropolis of Kankakee.
All right. So here is the NanoVNA in action. You see that? And what I have on there is, it looks like a Pi network that I was messing with. I don't know. And that little blue board is actually called a NanoVNA test board. And they're pretty fun to mess with because you can hook them up in line like this, and you can add different circuits, and you can test them, and you can adjust them and get all kinds of measurements. I will say that those test boards add a lot of capacitance to your circuit, so they require a little bit of extra stuff in there. But they're definitely fun to mess with. Now, when I got mine, they were not a complete thing. It was a kit. And when I say kit, I mean it came with all the parts required for assembly. So that put that together. And then here is another measurement of a 20-meter bandpass filter that I was messing around with.
You got a hump and a dip on that thing.
I sure do. So that's another nice thing about the NanoVNAs. I can get dual metrics like that. So what the hump is the insertion loss that you get at particular frequencies going through the device, and the dip is the SWR reflected back towards the device. So it was I felt extra nerdy when I was doing that. And then if I click on this one, this is just a SWR test that I did when I was testing out the toroid
video, wasn't it?
Yesterday's video, yeah. So I was just testing out the toroid for the Poseidon vertical antenna, which will be on the market.
Laplace. Did you do a Laplace transformation when you were doing that video yesterday? I saw a lot of math on it. I saw a lot of math. It made my eyes start to bleed a little bit, but
yeah, there was. So here's the actual paperwork from the video yesterday. You can see that there was some figuring that was done on there.
The boy was mathing hard.
Yeah.
So you can tell, I just want to point out real quick, you can tell that Ape doesn't do a lot of soldering because there is no burn marks on that mat.
Well, when I solder, what I do is I put an index card under the device being soldered so I don't burn the mat. So I've had this mat for like 15 years. Now there is some damage on it, but not a lot.
I'm on side 2 of my mat.
I'm on side 2 because side 1 has been melted a lot.
Melted, yeah.
Yeah.
Slagged.
But that's why you get it, so you don't burn your desk or your house.
I got
Right.
mine strictly for photos. I was like, I'm going to make
I
my
won't say
photos.
I won't say why I have mine.
I want my
And what's
photos to look good.
Chuck has his
what's funny
strictly
is
for
it's a
work.
I actually
it's a cutting
use
mat.
mine for what it's made
Yeah.
for.
It's a cutting mat for cutting fabric for sewing, Abe. You know that, right?
Right.
Yes. Yes.
I've got a silicone
I don't
mat
like to think about it that way.
that I try to solder on because it's made for soldering.
My mat identifies as a shack accessory to enhance my photo and video work,
Okay.
not as an old lady sewing table.
Or Chuck.
Right. All right. So then we have Smith charts, and that's one of the things that's really nice about the NanoVNA is it's a low-cost way to get into using Smith charts to understand a little bit more than just an SWR reading when you're looking at your antenna. And we're not going to go heavy into Smith charts. But I did want to talk a little bit about impedance. And when a lot of people, like I've seen a lot of people on YouTube go ahead and measure stuff with a multimeter and say, okay, well, this is 50 ohms. But what you're doing is when you're using a multimeter, you're measuring a DC current. And what you're measuring is actually resistance. You're not measuring impedance. So think about impedance as resistance for AC current, like what we use in our antennas. So AC is alternating current, DC is direct. It only goes one way. When you have alternating current, things behave differently when you change frequency. And so they have a formula for this where Z equals the word impedance, R equals resistance, and then you have something called JX, which is imaginary reactance. And that imaginary reactance changes with frequency.
Math is hard
There's
enough when
also
numbers were
JC,
real.
isn't there? Is that the imaginary capacitance?
No, he's
So-
the CEO of hip hop.
Oh, that's
Yeah,
okay.
he's
That's the
hip-hop.
one.
Right.
Yeah.
So on the Smith chart, you have some things called constant R circles. So that would be constant resistance circles, and they're the blue circles that are over on the Smith chart. It looks like spider web kind of. And then you have constant X circles. Now there are the arcs in green that are either inductive or capacitive. Inductive is on the north side of the equator. Capacitive is on the bottom side of the equator. They call them circles because they're technically circles that are not fully on the Smith chart, but a lot of people will call them arcs. So just something to think about. Now, anything along that center line, which I call the equator because it's easy to remember that way, is what's considered purely resistive. And what purely resistive means is there is no reactance. Any inductance or capacitance has been canceled out, and you just have pure resistance. So this is a screenshot that I took of the NanoVNA, and you can see there's a marker number 1, and that would represent an open load, and that is all the way over with an infinity SWR. If it was in the middle, it would be a matched, or I'm sorry, it would be at the system impedance of 50 ohms because we use 50 ohms for amateur radio. It could be 75 if you were using AV equipment. And if it was all the way over on the left-hand side of the equator, that would be, again, an infinity SWR measurement, but it would be for a closed circuit at that time. So here's a Smith chart that I got wormhole off of the big NanoVNA that I was showing earlier, and this was for a vertical antenna that I did a video on. And what I was able to do is I was able to say, all right, well, I want to measure my antenna at 40 meters FT8 frequency, and so I was at 7.0745, so it was just slightly off of the FT8 frequency because I didn't have a data point there. And my SWR is represented in the yellow line, and the measurement is 1.3 to 1. And I'm able to take a look at my marker on the Smith chart, and I can see that I have inductance there. And so typically what you would want to do to remove inductance is add capacitance. Easy way to do that is shorten the antenna. But there's other things that you could do using the LC function on your NanoVNA that we talked about earlier. And I can see my complex impedance of 40.7 ohms of resistance and 7.1 ohms of inductive reactance. Now that would be negative 7.1 if it was below the equator, but it's above, so it's a positive number. And I did a video on Smith charts recently that show you how to convert this to SWR and stuff like that if you really got the nerd bug biting you hard.
Many boffins died for this.
Yeah, and so like this is a picture that I took from the antenna handbook, and it kind of little talks about Sysjoint is a VNA manufacturer. Lee, so if you
that's that big one he was showing. Lee,
yeah, if you do
right?
just Google Sysjoint VNA, and they actually have a new one out, but that's even more money. So this is a page from the antenna handbook from the ARRL, and you can go check it out. The title's called SWR and resonance. And so a lot of times folks will say, hey, I only operate on resonant antennas. We're going to do a zoom in on this chart in a second, so you'll be able to see it a little bit better.
Yeah.
But resonance is when there's no reactance, right? We just covered that. So an antenna is only resonant at a data point on that line, the equator that goes across it. Any other point, you have reactance, and that reactance means you're not resonant. So let's go to the next slide where we zoom in on this. So point A, which is in orange, is resonant, right? Because it's on the equator, no reactance. SWR right there is 5-to-1. So if somebody was saying, hey, I only operate resonant antennas, but I operate on 5-to-1, you would think that they're crazy, right? Because we all know that from watching YouTube videos, 5-to-1 SWR is not good. And then point B is not resonant. That's this blue one up here, but that's a lower SWR of 2.44-to-1. So if given a choice, people would choose to operate a non-resonant antenna than the resonant one because it has a lower SWR. And they would think that they're closer to resonant when they're actually further from resonance. And I just put this in here as kind of like an eye opener so folks can understand a little bit about this SWR resonance conundrum. So when you look down here, point C, the green one, that's actually resonant, and that is 4-to-1 SWR. And so if this was my antenna, what I might think about doing is say that, well, from my radio to my antenna feed point, I have a 50 ohm coaxial line. So I'm not going to incur any power loss or reflections or any other stuff. I know SWR is a drama these days, all the way up to that feed point. And at that feed point, it's 4-to-1. So maybe what I would just do is build me one of these 4-to-1s, right? And put that at the antenna feed point.
And transform it there.
And I would transform it right there. I'm sorry, I'm going the wrong direction. And then that way I'm operating with a resonant antenna with an effective match that goes all the way through, albeit I'll lose a little bit of power in the transformation of my transformer. But it's just something to think about and give you options. I think that most people, when faced with this, they would just operate at 2.44 and then use their tuner and be done with it, right?
So Chris has a interesting question. If you have a trapped antenna like your Shorty 40,
yep,
what does that look like on a VNA?
Interestingly enough, we will be taking a look at that in about 2 slides.
So,
Okay,
so before
Chris,
you go
just
too far,
calm down.
yeah, before you go too far on that, the Shorty 40 is not a trap though; it's an inductor, right?
It is an inductor, but it does
Yeah.
operate as a trap. And the thing is that like I don't understand lexicon for amateur radio. So it's an inductor coil that you could technically argue is a trap or a filter.
Okay.
Right.
Because when you talk about a trapped antenna, you're usually talking about something that makes an antenna resonate at 20 meters, and then when you go to 40 meters, that same antenna, that trap is blind. It doesn't exist
Right.
anymore in
Yep.
the circuit.
Yep, 100%. And you also
So
lose
you-
your harmonics, right? Because
You
you
have
don't
to have multiple traps to call it trapped versus...
Well, it could be one trap. It could be a 20-40 dipole that's trapped at 20, and then it is 40
Okay.
meters long.
You could Liberty Cave, you could build a 5-to-1. All right, so if I come down here, this is my end-fed half-wave antenna, and I use the software to tune it. And so what you can see are 2 traces, a blue one and an orange one. So the blue one was my first shot at it, and then the orange one is after I trimmed it up a little bit to get it a little bit closer to thank you, Tom. To get it a little bit closer to where I wanted it to be. And then what you can notice here, a well-designed antenna for amateur radio will have these significant dips on the bands of interest, and it will have higher peaks on areas where you're not of interest. And that shows that it's working correctly. If you have a more of a flat line, you really probably have a lot of loss. Yeah, you have a lot of loss. And so things like that one antenna, I don't know, what is it, the Go Kilowatt that has a flat line all the way across, or that ICOM that we talked about a couple of weeks ago. I wonder what's going on in that matchbox. But this is the Shorty 40 that we were just talking about. And I do have a video on this. And this is an induction coil that I made. And this is a 49-to-1 antenna. And the reason I like this Shorty 40 is here's a typical on the top, a typical end-fed half-wave for 40 meters. It's 66 feet long. And with a Shorty 40, what you do is you make an induction coil at about 34 microhenries, and you can measure all this on your NanoVNA, and it's only 40 feet in length, right? So it's 26 feet shorter, and it makes it a little bit more portable and a little bit easier to put up in a smaller space. Now, what Tio was saying and totally dead on about it is that this is a 20-meter end-fed half wave with an extension on it to get you a 40-meter signal. So when you operate a 40-meter end-fed half wave, it's good on 40, 20, 15, 10, and 6 because they're all harmonically related. And so I can say that 15 is the third harmonic of the 40-meter band, and that's why it works. With a shorty 40, I lose 15 meters because I don't have a harmonic relationship to a true end-fed half wave at 40 meters. I have an adaptation of that, and that stops me from getting that harmonic relationship. I do get harmonic relationships on 20, 10, and 6, but
But you lose 15.
I
Okay.
lose 15, and then I gain 40 back. Now, when we take a look at this slide, that induction coil adds Q, right? Because when you start to add artificial, and maybe that's not the right word, but when you start to add artificial inductance or capacitance, your Q starts to tighten up, which means that your passes or your valleys are tighter. They're not as broad banded. Hey, Hollywood. And Hollywood put up with a bunch of questions for me last night. I was emailing him left and right. So thank you.
He's a brother.
That guy is such a huge help.
Hollywood,
bro.
just remember, I think he had some Miller Lights last night because he was discussing with us too. So just
I
saying.
did. And so what I wanted to point out is if you take a look at this slide, let me go ahead and hide this. You can see how narrow the signal is on or the dip is on 40, right? That's because I'm using that induction coil. And you can see on 20, it's wide again.
40 is the red one, 20 is the blue one.
Yeah, but then you can also see I don't have that same harmonic relationship with 15 that I did on this one, right? Because I don't have that harmonic relationship with the 40-meter length any longer.
Right.
So what's nice about the NanoVNA is I can look at this and I can see my Q, and you can even automate measurements of Q they have an analyze button in the software, but that's beyond NanoVNA 101. But I can see just exactly how I expect my antenna to behave. And I did the first swipe is the gray trace, and then the red is after I tuned it. Yes, 100%. You're really adding artificial length to it.
Bake it till you make it. That's right.
And then the last thing is people say, where do you buy a NanoVNA? On that nanovna.com website that we talked about earlier, there's a bunch of different links where you can buy them. I would suggest, if you can't wait, buy it from R&L Electronics. They're a mom and pop shop trying to carve out a lifestyle in the amateur radio space. We should be supporting them. If you can't wait, if you can wait, I would probably buy it from their AliExpress Zenco store. It'll be a lot cheaper, but it'll take you a month and a half to get it.
Mm-hmm.
And then Chuck got me a link for our zinc on Amazon, which I just dropped into the chat as well.
We have some questions
All right.
for you. So using the reciprocal property, the humps would provide a bit of signal rejection on receive.
Correct.
Yeah. Arnold, speaking of traps and resonant networks, he would be interested in learning more about using a grid FET, whatever you call it, dip oscillator. If we had one, maybe
We can actually build
we
one.
could do one. Yeah.
So if I understand exactly what you're talking about, in the old days they would call them a dip meter. And so when you would build a circuit, you would just dip that into the loop on the meter, and it would oscillate at the resonant frequency for that thing. So you can do that with a Rig Expert, and you can do that with the S11 port on the NanoVNA.
Yeah.
You don't have to do it with that way on the NanoVNA because it does have 2-port. But Jim, maybe we put one together with your Rig Expert and show it on the show. And then Chuck's got a Rig Expert too, I think. Don't you have the stick, Chuck?
No, I have the
He has
A30
the bottom end
35.
All right, well,
I bought it a long time ago.
Dude, for HF, it's all you need. You don't need to buy the $1,500 one.
Yeah.
I mean, unless
six,
you're
I wish it went to
freaking
6.
Honeywood, right? You know?
I went to 6 meter though. So
That was
but
my
I bought
first. I had
Comet
the 55.
for that.
That was my first one, was the 55.
The Comet's really nice too for what you pay and what you get is a pretty nice setup. And it will do
MFJ
similar stuff to what it'll do similar stuff that Ape's doing with multiple. It'll do the little bar graph. It's really small, but it'll save them. You can do different ones. So when you make an
MFJ
adjustment,
has
you can
several
rerun
really
it.
nice antenna analyzer meters.
They do.
The old MFJ one goes through batteries really fast though.
Oh, that
That
big
Comet.
the big square one. It looks
The
like a
one that
cinder
looks like
block.
the Comet. The Comet, the
269.
battery lasts a long time.
It's the 269, right?
Yeah, I believe that's right.
We've all had one. We've all been the dog. There's a Star Trek reference for you.
Lee
Dave.
is trying to start something. I'm just saying. With
Maybe the
his-
next video will be on radiation resistance, and you understand.
why Abe hates on ham sticks so hard.
I don't really
They
hate
work.
on them. I'd like to hate on them because it gets everybody in a fever. So I
Gets
just
riled up.
Steve,
Yeah.
can you drop a link for the SMA connectors?
I need
I
to
posted
figure it out.
I posted a link. Well, they're
So-
SMA male, female.
No, they're not. They're SMA female to SMA female. So they're not actually adapters. They're just they're port protectors is what Ape's looking for.
yeah. So
He's
they
He's
are
adapting
male,
it to itself.
but they are male to female.
They are male to female. They have to
Right.
be.
But then you
So
have to
type
find them
SM
that are not reverse SMA.
Yes. So here it is right here. It's got a male on one side and a female on the other. But you're
So
right.
I
You
need the
don't want,
link from Ape.
you definitely don't want the reverse SMA and stuff. That'll get you all boogered up. How do I fix this? I don't like being the center of attention. There we go.
Since when?
Well, yeah, you don't want the
Yeah.
ones that are RP SMA. That's correct. You
Right.
just want SMA.
So here we go. Thumbs
Yeah,
getting,
I searched Amazon for SMA male to SMA female, and what I got was 7 pages worth of this is not what you're looking for.
yeah.
Okay.
They don't make it easy to find what you're looking for these days with all the SEO tricks and traps that everybody uses.
That's how they get you.
I think that the punishment should be public shame and caning. You know, like I hate when I try to find something and I can't.
Yes, you can, Steve.
You just have to calibrate it out when you get ready to do your measurements.
Yeah, so that's where the finding PNC test standards or calibration standards is a little bit of a pain in the ass. I did get some at Orlando.
Yeah, so what Chris is talking about here is SMA covers that'll keep the dust out. And what Ape is talking about is SMA connectors have a limited lifespan of number of connections you can make. So he's multiplying that by disposable adapters. They're not really adapters. I mean, all you're doing is extending the port,
Yeah.
half a millimeter or whatever the math is. So
45.
all of
Yes, you do.
you wear it out on the $4 adapter instead of on the $50 NanoVNA.
Ape,
Yeah,
instead
and
of just
45
sitting there
depends on
looking-
what you're doing, right? So, like one of the things I might want to do is I might have a little amplifier circuit that I build, and if I want to test how much it actually amplifies, what I can do is I can use my NanoVNA, use the S11 port to inject a signal into the amplifier, but I don't want to feed that signal back into the other side because it'll be above the sensitivity point on this. So what I'll do is I'll put an attenuator line to do that.
Can you drop a link to the preferred attenuators you would use for these,
Yeah, sure.
like a 10 or a 20 or something like that?
Yeah, and
For the
some
people.
of the ones I like too are these little teeny ones, but
Yep,
you have to pay
that's the ones I
attention
was
to the
talking about.
power capability
And-
of these. I
And
think these
test
are
them
fun to watch.
often because they do fail.
Yeah, they definitely do.
And the beauty of this is you can also, if you can't find a 40 dB attenuator in that size, for example, you can add attenuators
can.
in line and they add up.
40 plus 40 is 80.
80,
Yep,
which
you
is
sure can.
insane amount of power that none of you people are radiating. So
Well, 70 dB is 1,000 watts. So just to keep that in perspective.
60 dB is 1,000 watts.
No.
Perhaps if we had some
Your turn.
vast
Your turn,
repository of knowledge that was searchable.
I'm going to Google it because 50 dB
50 dB is 100.
60 dB would be 1,000. It's another order of magnitude greater.
Yeah, I'm pretty sure. You might be right. I doubt it, but you might be
Mhm.
right.
Yeah.
It would be your one for the year. So, I mean, I'll give you that.
And the year is early. Oh, crap, Jim.
Burned it up already. And the other thing is I just rebooted my computer this morning, and now I have an icon on my
Yes, Steve.
toolbar that says Copilot Preview.
70 decibels is 10 kilowatts.
Okay. That's what I said, ain't it?
No. I want to be clear. You were wrong.
You were both wrong, is what I'm hearing.
I wasn't wrong.
No,
I
I
was
told
mistaken.
50. 50 is
was
100.
mistaken.
I knew that. Then it's 60 is
I was-
1,000 and 70 is 10,000. It's an
I was
order of
mistaken.
magnitude every time. Factor of 10. But you said anomaly completely correctly without stuttering on it. So go you.
So so I get points for that.
Right.
But that's all I had.
One day
that's
we'll
all
learn
I
how to
had
say
for today.
toroid,
That's-
but
that's all?
That's a lost
it.
cause,
That's it?
probably.
Hopefully that helped everybody.
I thought that was a decent presentation. Not too bad.
It was all right. It wasn't bad.
So that's the one I gave to the Bright Leaf Amateur Radio Club when they invited me on to give a presentation.
Did you was that a
nice.
live presentation or did you zoom it in your shorts?
I did zoom it in my shorts, and I did play a video that I have here, but I'm not going to play it today because we don't have time. But I did play a video of how to calibrate and then how to adjust for electric delay. But thank you, 73. So it looks like Adam Dennis changed his channel name.
Yeah,
did,
that's old.
yeah.
That's old
Yeah.
news. But
Yeah, he did.
It's like
It's old.
3 or
It's
4
a
weeks
couple
now.
weeks.
Yeah, thank you, Tom.
Yeah, Tom thought that was a great presentation, so you're not completely wrong.
So
on
did
this whole
Thumb.
thing.
Can you believe this guy?
We did a whole rig expert show a while ago, Thump. Where were you with all the
Yeah,
NanoVNA
right.
love during that show? I know how you
Yeah.
are.
Yeah.
Well,
Steve's asking the tough questions. Did you get that truck window fixed yet, Jim?
The truck window is going to be there until my daughter starts driving that truck, and then I'll tell her, don't roll down that dang window.
Don't roll
So
that
what
window
you
down.
need to do is open up pull the switch off the door, disconnect the wires, put the switch back on. That'll be
I
Mike.
need to Dalhofer proof it, is what you're saying. Is that what you're saying?
I would just duct tape it shut. I
Don't
don't
let
know.
Mike in your truck anymore.
Always offer Mike a ride and put him on that seat. Oh,
Put him
that's
on-
your seat.
Put him
there,
in the
Mike.
front seat or
How
something
do we get
like
a
that.
ham
No,
club presentation
Same,
for
the
any of
seat
you?
that's unhooked.
Yeah, so you can book the Smoking Ape on Cameo.com.
That's right. Yeah, Chris, just if you
Just-
want to
just
do
reach out.
something, just reach out.
Hit us
What
up
I
in
would
the
do with Mike
Discord
is
or
I
email.
would make him ride in the bed of the truck. That
Right.
seems to be the easiest way where he would do the least
Under the
amount
cover.
of damage.
Back with the Dr. Pepper cooler.
Right.
So we hang out with Mike a lot. But one of the things I've noticed is that he is destructive.
He's a
destructive in
tornado
nature.
of doom. Yes.
And he likes to let on that Frank is, but I don't know. I didn't
We
see
do
Frank open
offshore-
the window twice.
Offshore fishing, Chris. We're talking, we catch dolphins with that type of lure.
Yeah.
Some
Did he
sharks
ever get that?
hammerheads.
Did Frank ever get his laptop or Mike get his laptop fixed?
He
No,
did.
because he didn't
From
believe
Frank.
that I could fix it.
No, I think Mike fixed it.
Mike did not fix Mike's laptop.
Not that Mike.
Okay. All right. You're talking crazy, Chuck. I
Poda
thought you were
Mike.
having a
Poda
stroke.
Mike.
Somebody call 911.
Poda Mike. Poda Mike.
Okay.
All right, well, I guess that's it.
I
Unless
thought
anybody else has anything.
somebody fixed it. I think. I don't remember who it was.
Okay. All right. Hey, Covain. Haven't seen you in a while.
Covagna. Yeah.
Covagna.
I was thinking the same thing.
That's the French pronunciation, Covagna.
Right. Furrier.
It sounds like
or
a
Fourier?
fancy cheese or champagne or something, right?
Right.
Sounds like a cool name, is what it sounds like.
Is Lee still in here?
I'm sure Lee is
Probably.
here.
Sure he's
Lee is
poking
always here.
around.
I can't believe
Lee,
Don was
shoot
not
me
here
a
to throw
shoot me
turds
an
at
email,
Dave.
Lee.
Don
We'll
doesn't
talk.
like the NanoVNA. Why would he watch? He might change his mind.
Right.
He's probably
Well, you
working.
know, Don got up and was like, "I'm not watching that boys talk about the NanoVNA. I don't trust it. I'm going to use my ham stick."
Right?
No,
So,
it wasn't
you're
that
right,
Mike that
Lee.
fixed it.
Lee gave me
It
grief.
wasn't
about
him
the-
that fixed it.
about the radials and I did a ground plane video. He had to ask the hard question.
Oh,
where I had
those-
to double check the manual for Lee. I wouldn't have done that for anybody else.
Right.
You cannot, Steve. You need a VNA. I mean, an essay for that.
Tiny
You
essay.
need an essay, a real essay, a tiny essay, some sort of essay.
I get him
Say-
confused.
Yeah.
Well, that's
I
and
bet
that's
he did
probably a
update-
show we should do.
update
We can
mine.
Ape, give us a quick rundown of the difference between because the word gets thrown out a lot: a scope, an oscilloscope,
You know where mine's at.
an SA, and a VNA.
Yeah. So,
Hey,
with a
ASA.
VNA, you use it really VNA to characterize a device. Now you can do that with all the other things as well, but the NanoVNA generates its own signal, and it uses the strength and the composition of that signal to go through something and then measure the behavior of that device under test. Now you can do that with a spectrum analyzer that has a tracking generator. You can do things like through measurements and stuff like that. But what's really nice about the spectrum analyzer is you're measuring not the behavior of the device, but the characteristics of the signal at that point. And if I get this wrong, I'm sorry.
I'll correct you.
But what I like to do with a spectrum analyzer is take my signal and measure what that signal looks like. Now, I may measure that through a device, but I'm looking at a signal that is generated by either a signal generator or a radio, more importantly, a radio. So if I want to know how my radio behaves when I amplify the signal, then I would use a spectrum analyzer for that. If I wanted to measure the insertion loss of a known calibrated signal through a device like a amplifier, then I would use the NanoVNA. Now, VNAs and spectrum analyzers measure essentially voltage over frequency, right? So your arrow pointing up is your amplitude, and then the arrow going side to side is your frequency. With an oscilloscope, which does pretty much the exact same thing, your domains are voltage and amplitude on the up and down, and time across the horizontal. And so you're able to see how your signal behaves over time versus at a particular frequency.
And a VNA,
the elevator.
That's pretty good. A VNA kind of rolls those two functions together and does some Laplace transforms and some Fourier transforms to merge those functions into some more complex functions that neither an SA or a scope can actually
so
do.
if I was looking to get into testing stuff, I would buy the VNA first, the SA second, and oscilloscope third. Is
all right.
The order I would go in.
That apparently lit a fire amongst the people.
Thank you, Chris.
Chris, thank you for the super chat. And KO4AFL was on our show the whole entire time when we were talking about radio stuff. So they may kick him out of Clubhouse. I don't know, but
Steve, we got you.
Steve, thank you, bro. That was awesome. And Thanks, then Steve. Jeff has been a member for 11 months.
Yep. Thank you, sir.
Yep. And Mr. Stephen Reynolds has been a member for 6 months. And we appreciate y'all.
So members are going to get first crack at the Poseidon antenna. And somebody asked the instructions are about 25% done. I just need to get to doing a couple more pictures and a little bit more on that. And so hopefully that'll be available soon. Yeah. And so the general release is waiting for more antenna frames. So we ordered 100 frames and we haven't gotten them yet. So
there was a small manufacturing defect and we don't put up with that shit here. I said,
right.
You're like, take that and you shove it where the sun don't shine and make me some new ones.
Steve was very forceful.
What they tried to do is they wanted to give us the damaged frames at a lower price. And we didn't want to do that. So we were like, I know we could pass cost savings on that way, but
so what you're going to see in about a month or so is counterfeit frames on the market that are slightly blemished that do not come from
probably.
Right.
I would not be surprised if someone
there's a lot of those
anyhow,
right?
Those on Etsy.
Right. We are often
there's a lot of those anyhow.
There's a lot of 3D printed counterfeit frames floating around because somehow pretty much stuff ended up where it shouldn't have been.
Right.
Yeah.
Right.
Well, I've seen those, and they don't quite get everything right, but they're close.
They're close. They're close,
except for what they're
close enough for an IP conflict. Yeah. Chris Radio and Life member for 6 months. N2MAK New York Mike has been a member for 5 months. He's looking forward to the Poseidon. Mike, are you going out POTA today, son? Because I'm gonna try and hit you.
He
up.
Probably
of course,
is.
Mike is going out POTA today.
I know that's like asking if the sun doesn't shine.
I want to share a little story that we had yesterday.
Oh Lord.
And this is about Apis tested our Poseidon stuff how many times now?
A lot.
A lot. So yesterday he tested them, and I guess he had a bad connection. He's like, hold on. We got to stop production. Stop production, you know?
I was like, stop making the kits, Chuck. Stop making
And then I said, did you forget to divide by 2 again? And he goes, hold on. Oh, we're good.
It's fine.
It's fine.
Here's the test setup I was doing, and one of these things was loose. Is what the problem was. But I immediately went into panic mode because I was like,
he did. I was like, oh my God, here we go. It's not the first time this has happened for this antenna because we want to make sure it's right, and just testing it, making sure it makes contacts. I mean, there's other antennas that aren't that great that make contact. So,
well, what I was doing is that let me see if I can find
like
it.
ham sticks, for example.
I was comparing. I wanted to do one more comparison test of the green toroid to the FT140 43.
Mm-hmm.
And the reason I wanted to do that is because I know people will they're going to bitch that it's a powdered iron core, not a ferrite core. And when I did
That's
it,
all you
the
want. Work.
ferrite core had more loss in it than the powdered iron. But I just wanted to double check it. And when I double checked it, because of the loose connection, the powdered iron looked pretty bad. And I was like, about fell on the floor.
Well, plus the powdered iron will tune up with a so far I've been able to tune up with an internal tuner. You may need more tuner than that, but so far it's been pretty good most places. Because we did it in Florida and it was fine. I don't know how many. I know Kyle did at least 3 different bands on it, right? And Jason did 10 and 20. So some of your main ones for sure.
Yeah, we had sideband and CW, and I don't know if anybody did FT8 on it. I don't remember, but I know Kyle was over there.
CLC.
Don't
Don't blow out an O-ring moving stuff.
The cores are pretty much unobtainium.
They are.
Yeah.
So Mike is asking, are we going to do 100 feet of wire width up a side? And that means that you get plenty of room for radials.
Yes.
Yep.
Yes.
You do. So
More radios, more
You can do multiple things, and I know where Mike's going with it, I think, but it's kind of up to you. I don't know if that's going to be in instructions or not.
A quarter wave on 40. Is that the idea?
So it's a 25. It's about 25 feet vertical, and then you would use 4 17-foot counterpoises, which comes out to about 82 feet of wire use. So you'll actually have about 18 feet of wire left.
Just enough to not
Why
do
not
anything
make
with.
another counterpoise wire?
Yeah,
Right.
and
But you could also to get a little bit better, you could make an add-on and make one of your radios that you can add on once in a while if you want to do some lower stuff, right?
yeah, it is a 4 ground plane antenna, Chris.
Yes.
And they're 17-foot ground plane radials.
So there's plenty of wire for it. And that's basically,
All right.
that's where all of our antennas are coming with 100 feet now. So
Now you could add more radios on there if you want, or you can.
yeah, you could.
We sell it as a development platform with a recommended configuration.
Right.
I would use a choke with it, and I would
Recipe
also
suggestion. Serving suggestion.
and you should use a tuner with it.
And I've used a choke every
Sure,
time
why
I've
not?
used it. Just the beads on my coax. It did.
Right, which ABR sells coax with those built in.
They sure do.
Yeah.
And they have some really nice POTA-sized coax. Because this is
and don't
like
go for
all our
that stuff
antennas,
that's
more
colored.
of a-
Sometimes I've seen some of that stuff that's colored.
But it's great
and
cable.
Yeah, for sure.
Oh my God.
It's awesome.
like
So you
flexible
can't
cable.
lose it. And there is a link for ABR in the dingus down below. Chuck's and Steve's
You guys
faces.
just did TOU and Chuck both dropped
We did.
videos yesterday using one for
Yes,
a POTA
I've got
activation.
2. We did it at Arizona out in Quartz Fest at Kofa National Wildlife
Mhm.
Refuge, and then we did it in Florida at Lake Louisa State Park and had
Yeah.
fantastic results. Kyle was getting massive DX on it in CW mode.
He
Yeah,
was.
it was. I was thinking we'd get more DX, and I don't know. I don't really know what Jason got because I didn't hear him get any DX, but I'm sure from Florida you can, especially.
Okay.
All right, that's it. Hit the button. Thank you, everybody. Much appreciated.
Thanks, everyone.
Fellas, y'all have a good day. See ya.
See you Thursday.